Hello, this is Mridula and this is my Physics 2212 Lab 3 video circuits. The purpose of this lab video is to predict the behavior of circuits with series or parallel resistors, capacitors, and to use multimeters to measure the current and potential differences in the circuit. A preview of the main results. In the circuit, the nodal and the loop rule holds true. In an RC circuit, the current is time dependent and based on exponential equations. The principles used in this lab are the nodal, which is current flowing in through a node is equal to the current flowing out of the node. So as you can see in the image, I1 plus I2 plus I3 is equal to I4 plus I5. Loop rule. The sum of the potential differences in a loop in a circuit is zero. So as you can see in the image, VAB plus VBC plus VCD plus VDA all equates to zero. And the last principle, Ohm's law. Current which flows through a conductor is directly proportional to the voltage across it and inversely proportional to the resistance. In this experiment, the system is a circuit and the surroundings is everything else. We have to find I1 and I2. So each battery has 1.5 volts. Our total is 147 ohms as the resistors are in series. I is equal to 3 volts by 147 ohms, which gives 0.02 ampere. So therefore, I1 equal to I2 is 0.02 ampere as the current is same everywhere in a series circuit. The actual reading is 0.02 ampere as well. And if you reverse the connections of the ammeters, there's no change in reading. So the next condition is what happens when you replace an ammeter with the voltmeter. The ammeter reading is going to be zero due to the high resistance of the voltmeter, and the voltmeter reading is 3 volts as there's no other voltage drop across the circuit. So now we're asked to find the potential difference across each part of the circuit. So only points V of A, V of C, D, and V of E, F have voltage drops, as there's either a resistor or a battery, but V of BC, V of DE, V of FG, V of GH, and V of HA has a voltage drop of 0 as there's no node or resistor in those locations. And by following the loop rule, the sum of all the voltage drops should theoretically be 0. And if we add up all the measured readings, it does equate to 0. So for observations, the graph shows the potential differences across different parts of the circuit. So from A to B, there's a voltage gain due to the batteries. From C to D and E to F, there's a voltage drop due to the resistors. And the sum of the potential differences all add up to 0. So for the question, the ammeter reading does not change because there's very high resistance, so less current will flow through the circuit. So if you replace the voltmeter with an ammeter in parallel with the 100 ohm resistor, the ammeter has low resistance, so the current will flow through it instead of the 100 ohms resistor, due to which the effective resistance is lower to 47 ohms. So if you calculate the current, it's 0.06 ampere. For this part of the experiment, we have to calculate the resistance value. So for the 47 ohm resistor, R is equal to 0.96 volts by 0.02 ampere, which is 48 ohms. R100 is equal to 2.04 divided by 0.02, which gives 102 ohms. And for the resistance of the wire and ammeter, it's equal to 0. Next up is RC circuits. So when the 10 ohm bulb was connected in series to the capacitor, it took 11 seconds for charging and 10 seconds for discharging. And when the 20 ohm bulb was connected to the capacitor in series, it took 22 seconds for charging and 20 seconds for discharging. So if you look at the charging and discharging value, it's almost similar for both the 10 ohm and 20 ohm bulb. The RC circuits graph shows the relationship between ln delta V by delta V naught versus time. So as you can see, there's a linear relationship. The predicted RC is 30 ohms times 0.2 Faraday, which is equal to 6. And the experimental RC is 1 over the slope, which is 1 by 0.1668, which is 5.995. So as you can see, the predicted RC and the experimental RC are almost the same. Next up is assumptions and sources of error. So the assumptions made in this lab are the resistance of the wire and ammeter is negligible, and EMF is equal to V cap plus V resistors. And the error encountered could be human error for stopping the stopwatch for charging and discharging the bulbs. So for this question, without a resistor, the capacitor would charge instantly, and this prediction would not happen in real life as batteries have resistors. The measured time is different from the predicted time as the ammeter would have resistance, which limits the total current. Thank you.